Most people still believe that stealth aircraft like the F-22 and F-35 are basically invisible, that once they enter the sky, they disappear from the battlefield. Untouchable, unseen, untargetable, but that idea is outdated, and more importantly, it was never fully true to begin with. Because stealth was never about invisibility, it was about delay in detection, delay in targeting, delay in reaction. And today, even that advantage is being challenged in ways most people don't understand. So here's the real question. If stealth isn't invisibility, then how are aircraft like the F-22 and F-35 actually detected? And more importantly, what does that mean for the future of air combat? Now, before we go deeper, if you want real explanations of modern military technology, stealth systems, radar physics, and how these systems actually work in the real world, subscribe to VectorTechExplained, because here we break down complex systems into clear ideas without hype or myths. Now let's get into it. The concept of stealth is built around reducing something called radar cross-section. More in simple terms, it means making an aircraft reflect as little radar energy as possible. When a radar system sends out a signal, it expects that signal to bounce back after hitting an object. The stronger the reflection, the easier it is to detect and track that object. Stealth aircraft are designed to scatter that radar energy in different directions. Instead of reflecting it back to the radar source, they deflect it away. Combined with special materials that absorb radar waves, this significantly reduces how visible the aircraft appears on radar systems. But here's the critical part that most people miss. Reducing radar visibility does not eliminate all forms of detection. It only affects one part of a much larger detection ecosystem. Because modern air defense is not based on a single radar anymore. It is based on networks. And this changes everything. Today, detection systems use multiple sensors working together, different frequencies, different technologies, different perspectives. And when you combine all of these, even small signals can become meaningful. Now, let's start with radar itself. Traditional radar operates in higher frequency bands. These are more precise, but also more affected by stealth shaping. This is where aircraft like the F-22 and F-35 are optimized. Their geometry is specifically designed to minimize detection in these frequencies. But lower frequency radars tell a different story. Long wavelength radar systems interact differently with aircraft surfaces. Instead of being easily deflected, these waves can resonate with the structure of the aircraft itself. This means that even stealth aircraft can produce detectable signatures under certain conditions. Now, these systems are not as precise. They may not give an exact targeting solution, but they can provide something just as important: awareness. And once you know something is there, the game changes. Because detection is not a single moment, it is a process. First, you detect something, then you track it, then you identify it, and finally, you engage it. Stealth mainly delays the first step, but if other systems compensate for that delay, the advantage begins to shrink. Now let's move beyond radar. One of the most important detection methods today is infrared tracking. Every aircraft generates heat. Engines produce extremely high temperatures. Friction with the air creates additional thermal signatures. Even the surface of the aircraft heats up during flight. This heat cannot be hidden in the same way radar reflections can. Infrared search and track systems, often called IRST, do not emit signals. They passively observe the environment, looking for heat differences. And this is critical, because passive systems cannot be detected in the same way active radar can. There is no signal to warn the aircraft that it is being observed. This means that even if a stealth aircraft avoids radar detection, it can still be tracked through its thermal signature. And as sensor technology improves, this becomes even more effective. Modern IRST systems are capable of detecting targets at significant distances, especially in high altitude environments where temperature contrast is more pronounced. Now combine this with data from radar. Even if radar only gives a rough position, IRST can refine that information, and suddenly you have a much clearer picture. This is where sensor fusion comes into play. Instead of relying on one system, modern air defense networks combine data from multiple sources: radar, infrared, electronic signals, even visual tracking systems. All of this data is processed together, patterns are identified, movement is predicted, and uncertainty is reduced. And this leads us to one of the most important shifts in modern warfare. Detection is no longer about seeing something clearly. It is about building enough confidence that something is there. Because once that threshold is crossed, action can be taken. Now let's talk about electronic emissions. Aircraft are not just physical objects. They are also sources of electromagnetic activity, communication systems, data links, radar systems, electronic warfare equipment. All of these can produce signals. Even when operating in low emission modes, there is still a risk, and these signals can be intercepted. Passive detection systems can analyze these emissions, determine their origin, and even classify the type of aircraft based on signal patterns. This is sometimes referred to as electronic intelligence, and it adds another layer to the detection problem. So now we have radar, infrared, electronic signals, but there is still more. Modern battlefields are increasingly networked. Different platforms share information in real time. Ground-based radars, airborne early warning systems, satellites, other aircraft. Each one sees a piece of the picture, and when those pieces are combined, the result is far more powerful than any single sensor. This is why the idea of complete invisibility is no longer realistic, because you are not trying to hide from one observer, you're trying to hide from an entire system, and that system is constantly evolving. Now let's bring this back to the F-22 and F-35. These aircraft are still incredibly advanced. Their stealth design gives them a critical advantage, especially in the early stages of an engagement. They can approach closer, gather information, and act before being detected. But that advantage is not absolute. It is conditional. It depends on the environment, the sensors involved, the tactics being used, and this is where strategy becomes more important than technology alone, because stealth is just one tool. Electronic warfare is another. Decoys, jamming, deception techniques. All of these play a role in how an aircraft survives and operates. And increasingly, success depends on how well these systems are integrated, not just how advanced they are individually. This brings us to a key idea. The future of air combat is not about a single dominant technology. It is about systems working together. Stealth aircraft like the F-22 and F-35 are part of that system, but they are not the entire system. Other aircraft provide support. Electronic warfare platforms disrupt enemy sensors. Command and control systems coordinate actions. And weapons can be launched from platforms that are not even directly involved in detection. And this is sometimes called distributed warfare. And in this model, the aircraft that sees the target is not always the one that engages it, which means survivability is no longer just about being invisible. It is about being connected. Now think about what this means. If detection is becoming easier through multiple systems, then the advantage shifts to those who can process information faster, who can make decisions faster, who can act faster. Because in a complex environment, speed of understanding becomes more important than pure stealth. And this is already happening. Artificial intelligence is being integrated into sensor systems, automating detection, enhancing tracking, reducing human workload. This allows for faster reactions and reduces the effectiveness of traditional stealth strategies. So when people say stealth is over, what they really mean is this: stealth alone is not enough anymore. It is no longer the dominant factor. It is one part of a much larger equation, and that equation includes sensors, networks, electronic warfare, data processing, all working together so are the F-22 and F-35 obsolete. Not even close. They are still among the most capable aircraft ever built, but their role is evolving. They are no longer invisible hunters operating alone. They are nodes in a network, contributing to a larger system. And that system is what determines success. So the next time you hear someone say that stealth aircraft cannot be detected, remember this: they can be detected under the right conditions, with the right systems, using the right combination of technologies. But detection does not automatically mean defeat, because modern air combat is far more complex than that. It is not about being seen or unseen. It is about timing, positioning, information, and coordination. And this is where the real advantage lies. If you want more deep dives like this, where we break down how modern aviation and military technology actually works, subscribe to VectorTechExplained and tell me in the comments, what matters more in the future of air combat, stealth, or the systems that detect it?